Hi everybody, Scott here from NAMC, North American MiG Consortium, also E3 Scott from the RC Powers Forum. Today I wanted to do a walk around, or sit around I guess if you want, on a modified F18 version 3 from RC Powers that I built. Just a little bit of a background on this. I grew up in the Canadian Forces as a fighter controller, air traffic controller, so I sort of grew up with the F18 or CF18, so it's always had a soft, special place in my heart as a real plane and as a model. When the F18 came out in June of 2013, I was sort of at the stage of my RC career where I was looking for something to, sort of push my skills and my confidence to the next level, and the F18 definitely did that, along with the MiG-29 version 3. This is the fourth one of them that I've built. One of the previous ones that I built, I had about 350 flights on it before I retired, and it was just an excellent airplane. Learned, developed my high alpha skills. Used it as a test bed for about 8 or 9 different motors. Just had an absolute blast with it. So anyway, I got involved in some other things when Stefan and I got going with NAMC initially, and we got joined later by our third partner Dave. We got involved in playing around with the MiG-29, which eventually led to our NAMC MiG-35 and then NAMC MiG-FA. But on the back burner, I'd always there were several modifications that I wanted to try with the F18, and I did build a modified F18 sort of just before the version 4s came out from RC Powers, or right around the same time, and as Stefan and I took off, so to speak, with our projects from NAMC. So it sort of always has been simmering on the back burner. And now that I've, fast forward, I've learned a lot of things about, different scientific principles that, Stefan has helped me learn and understand. And other things that I found sort of as the head test pilot at NAMC, if you want, about airplane setup and performance. I wanted to bring many of those principles across to a more straight wing airplane. Obviously the MiG-35 and the MiG-FA have a far more swept wing, almost like more of a modified semi-delta, I guess if you want. Whereas the F18 is a much straighter wing. In fact, the trailing edge is almost swept forward instead of swept back like it is on the MiG-29. So I wanted to, I was pretty sure in my mind that many of science is science, so I was pretty sure many of those principles would carry across. But you never know until you glue some foam together, take it to the field, and give it a try. So that's sort of my background of how we got to this point. I also want to, at this point in time, before I forget, I want to give out a shout out to Splash Balls. He's from Australia. He's a member, one of the newer members on the RC Powers Forum, and he and I have been exchanged several conversations as he's building his F18, and things are a little quiet for us here at NAMC right now, as we have other things going on in our lives. So this kind of, his discussion with him and his excitement over the F18 motivated me to dust off a set of plans I had sitting in my closet and get going on this plane. So thanks very much to you, Splash Balls, for getting me motivated. So essentially, I'm just going to kind of I won't go over my build, what I used and all that sort of stuff in detail. If you check down below in the comments, I'm going to have multiple links. I've already written, I think, about 3 different reports as my build process went along, and 3 flight reports. I already have 28 flights on this plane, and I thought that rather than doing the walk around before I flew it, I would do it now, because now I'll be able to give you feedback, on how I saw the changes that I made on paper and during the build transformed, or translated, I should say, over to performance in the air, which is what the most important thing is. I mean, we wouldn't build these things to fly if they didn't, we didn't take them out and fly. But essentially, what I wanted to be able to do is, initially, what I did was I went to Wikipedia and I looked up the dimensions. I wanted it to be a bit more scale dimensions with respect to length versus wingspan ratio. I always felt that the stock model was a bit too long. I should also interject right now, you know, kind of a disclaimer. If you're brand new to the hobby, brand new to park jets, go to the RC Powers website. There'll be links below. Sign up, get a membership. You'll get plans for this plane free. You'll also get plans for the MiG-29 version 1, which is one of their most popular and simplest build, and just a ton of fun for very little outlay of money. If you want to build this plane, I would strongly encourage you, build it stock, i.e. per their plans with all their recommended gear. Follow their instructions, you know, play around with it, and then you know, you can play around with modifications afterwards. Some of the modifications I'm going to talk about are form, which means, you know, I wanted it to look a certain way. You may not necessarily want it to look that way. And the other part is function, and you may not necessarily want your plane to fly how I like to fly. I'm a firm believer that the only person you have to keep happy when you're standing at the side of the field with your transmitter in your hand and your plane is zipping around is you. So don't, you know, if you don't want to do any of this stuff, or none of it makes sense to you, or you really don't care, then don't worry about it. My feelings will definitely not be hurt. I just wanted to share some of these ideas in case you're, I've already flown the F-18, or you've been around the hobby for a while and are, you know, looking for something new to try, as for many of us in the Northern Hemisphere, our main build season is coming up here very shortly. Okay, so now that the legal part is out of the way, I guess, so to speak. So what I did, I went to Wikipedia and I found, you know, I looked at the dimensions of the regular, of the F-18AB, the CF-18, and the Super Hornet, and took the length and divided it by the wingspan to get a ratio number. And then I took did the same thing with the model, and I found out that the model, the ratio, the model was, this model was longer than obviously than the real plane. So I wanted to try and bring down that the length of it to give me that same ratio as the real thing. My other philosophy was I was driving towards trying to make this plane more agile, quicker and agile, more maneuverable for aerobatics and just general flying, you know, just to kind of give it a little breath of life there, make it, you know, more of a bit of a sports car handling kind of thing. So I knew that obviously, you know, when you're talking about simple physics, the longer a lever is, the more effort it takes to you know, to tilt that lever. So if you have a shorter lever, it doesn't take as much to turn it. You can turn it more quickly, takes less force or less surface control surface deflection, all that sort of stuff. So that was kind of what I was driving at. I was looking for something that would make this airplane quicker, more agile, and more precise to suit my flying needs, and also, again, as I mentioned, to experiment and see if what I learned from other planes of a very different style would translate over to this one. So in effect, I ended up, I've shortened it by about almost 2 inches, and I didn't, you know, just go, okay, I'm going to lop 2 inches off the nose. That would look ridiculous. I shortened it up both at the front and at the back in a couple of different ways. And I also lengthened the wing just a tiny bit, maybe about 1/4 of an inch. Whether I really needed to do that or not, I don't know, but I guess, you know, just to make the formula happy when I did the math, that's how it worked out. I also, the other major change that I made to it was I wanted, as part of my plan, is I wanted to be able to pull all of my electronics closer to where my center of gravity is going to be. This airplane, as it sits here right now without paint on it, weighs about 21.1 ounces. The electronics for, you know, the motor, receiver, speed controller, battery, and all the servos. You can see my servos, other servos for the aileron and elevons are on the bottom. They make up 60% of the weight. So what I wanted to try and do is get all of that weight in as small a section of the airplane as possible, because and also get it close to where my center of gravity is going to be. Because if you think about it, you know, you take a big long stick, you try and balance it on your finger, it's harder to get that to balance. If you take a pencil and you try and balance it on your finger, it's much shorter lever, it's a bit easier to balance. So when you get a plane where you can get all of that stuff concentrated, you get the laws of physics working for you rather than against you. So when you go to turn, rather than having a big long lever you have to try and move, it's just a very short lever, and by having the weight concentrated around that pivot point, it just makes things a lot easier. When I flew this stock, I used to balance it on the stock CG, and here's the, you won't be able to see it, but up here, this is where the bulkhead is, where the nose former is, and I used to fly it with my battery all the way up here, and now you can see my battery is way back here, so it is a lot closer. This lever here before, if you took from the back of the motor up to where the battery was, it was about 18 inches long. Now my moment is only, where all that stuff is only about 9.5 inches long, so it's a huge difference. I also wanted to experiment a bit more on getting the KF airfoils dialed in with respect to their dimensions. As I found out with testing the NAMC, the NAMC planes, there is a direct, as you really start to push the envelope, there's kind of a direct relation between where your CG is and where your center of pressure is. Obviously, those two things are on every airplane. And the KF, where the trailing edge of the KF is, has a big impact on where your center of pressure is. And if you get those too far out of whack, what happens is how you notice it in the air, or how I noticed it is, say you're coming out of a big, big fast power dive, after a split S or a loop or something. And what I found was happening is, if my center of pressure was too far back, it really took a lot of effort to get the plane to rotate to come back to level or climb out again. And as I got, by playing with the KFs and moving the center of pressure forward and the center of gravity slightly back, you get to a point where you really feel those working in harmony. The other thing that would happen is, if I get up in a turn, sometimes the nose would start to wander around, or the plane would just feel sloppy. It was like trying to fly a 3-year-old toddler throwing a bit of a temper tantrum, if you kind of know what I mean. So anyway, again, these are things that are maybe way too technical, way beyond what you ever want to do, but I know there are guys that are interested in just playing around. I mean, it's only foam, so it's it's a very cheap way of learning and really dialing your planes in to fly the way that you want them to fly. All right, so let's talk quickly about how I got the thing shortened up and looking the way that it does. So starting at the front here, again, some of this is form, some of it's function. I always felt that the F18 had a bit of a longer, pointier nose. Now this may not be even a scale nose, maybe it's too short now, but I like how it looks. And so what I did essentially was, all these, you got a bunch of fingers up here at the front that you sort of squeeze together to form the nose. I essentially just drew on the paper plans, and I shortened this by about 5/8 of an inch. And then by the time I formed it together, I probably ended up shortening the nose by a little bit more than that. So moving back, again, as I mentioned, right here there's a bulkhead, and then forward of this is the nose former that allows you to form the nose here. So I cut 5/8 of an inch off of that as well, just to keep everything proportional, and also to lose a little bit of weight. The F18 version 3 especially is one of the most weight sensitive planes I've ever built and flown. I learned that the hard way. I built my very first one way too heavy, about 26 ounces, and coming out of a power dive, my wing flexed so bad it snapped, and I wrote the plane off. So since that, I've really focused on trying to keep my planes lighter, and I found that this plane is, once you get up to about 22 ounces, if you start to go beyond that, it's hard for you to really do any serious high G maneuvers and aerobatics, because then you really put a lot of stress on the wing. Okay, so you can see my canopy here. What I did with my canopy was I made it a bit more oval and teardropped, both because I like how it looks, and also to try and make it a little bit more sleek aerodynamically. That was just a very simple thing. There's a centerpiece here and a centerpiece here. All I did was I just trimmed a 1/4 of an inch either side so it's more angled in, and then when I glued it on, I just bent these two side pieces in so that it's has a more teardrop or oval, I guess, type shape. You can see here on the top I've extended, normally when you build this, your KF airfoil on the top would just come straight in here to the side. So what I did was I added on this piece that goes along the leading edge root extension, or the lurks. I did this once already on one of my F18 modifications and instantly noticed just a much smoother feel to the plane, smoother and more stable. And you'll notice now that like with the version 4 and several other park jet designers, including us, we at NAMC, we've incorporated that into our planes. It just makes, just on the top though, not on the bottom, makes the flying experience more smooth and stable. Okay, when I put these on, one of the things I did with the wing, because I moved some stuff forward in the back here, I trimmed about 1/4 of an inch off the back of the wing right off the get-go. So I took 1/4 of an inch off the back of the KF airfoils as well before I installed them. Alright, so getting to the motor, as I mentioned, I moved the motor forward 1 inch on the plans. And I took some pictures, again, in one of my blog posts that I'll link below. You can sort of see what I did. So I had to make some adjustments in here, trimmed 1 inch off of the fuselage. I also had to trim the back here of the nacelles to make sure that the prop had clearance. So again, I just had to sort of make an adjustment of 1 inch to sort of everything because I moved the motor further forward. You can see here I also did kind of my own thing. I sort of just took a wag, or a wild ass guess, as we used to say in the Air Force, as to where my center of gravity was going to end up being. So I put my elevon and aileron servos close together here to sort of where I think my actual center of gravity is right about here. Actually, my finger, I think it's right about here now. So my servos are really close to that. I also am experimenting a bit with a different wing reinforcement plan. It's tough for you to see, but because I moved the motor forward, now to have a main wing spar, I reduced, normally I'd be back about here, and I'd probably be, if you wanted to be able to have a spar almost from wingtip to wingtip. Because I moved the motor forward so much, I reduced my ability to do that. So down the center here of the, from about here to here, I have about a 16.5 inch piece of 4mm carbon rod, really stiff. I didn't come up with that length mathematically. I just happen to have some scrap pieces laying around that I'd recycled from another plane. And then I have kind of basically right here, and maybe you can see in here, the tip of it. It's about a 12.5 inch piece of 3mm carbon tube. Again, nothing scientific there. Although what I did was I made sure that I measured, and you might be able to see in here, was I wanted to tuck the end of the this piece underneath the nacelle. So when I glued the nacelle on, it was going to lock that end piece in here nice and solid, to help reduce any wing flex. Granted, compared to stock, it does add a few extra grams of weight because of the extra carbon, but so far flying, I've done several times. If you want to sort of see how your wing is flexing, what I find is if you're out in the field and kind of come towards yourself or away from yourself in a, give her the juice and pull a pretty hard turn, you'll be able to see. If your wing is really quite flexible, what you'll start to see is that the ends out here will actually bend up. Like the one F18 I was telling you about before I wrote it off, God, it looked like a glider almost. The wings were bending up like almost an inch at the end here. So that's kind of an indicator that I look for to see if my wing is strong. And thus far I'm really happy, even though I did add a few grams of weight. It gives me a super strong wing, especially since this piece here is locked under, sandwiched in the KF4. Okay, I put my rudder servos here. I probably could have put them a little bit further forward, but because I was going to be playing around and testing with this, and I wanted to have the ability to be able to trim off the back of my KF, I put them here out of the way so that I wouldn't, end up with this situation where I'm trying to measure, keep a consistent angle or whatever, just made it easier to tuck my rudder servos back here. So if I was to do it again, I might move my rudder servos forward a little bit and just cut like a relief out of the KF, you know, just to do that. But actually my servos pretty much all go like bang, bang, bang here, so they're all pretty close together. All right, so before I talk about other stuff, what I did in the back end here to help shorten it, let me talk about the ailerons first. These ailerons are stock width here in the cord, but I think they're 7.5 inches long. I like my ailerons, or I guess you could, you know, maybe you wanted to call these flaperons because they're more in the location where the flaps would be. But I like my ailerons to be, I found through testing and modifying other planes, and then through our testing and development of the two NAMC planes, the MiG-35 and the MiG-FA, is that ailerons that are about 60% of this distance here seem to be ideal for best all-around performance for turns, aerobatics, for use as flaps, use as spoilers, that sort of stuff. If you're doing, you know, any sort of extreme flying like high alpha, that sort of stuff. Again, it's just something that, you know, you might have to play around with. The other thing I like is that because I don't have a big surface area moving out here at the tip of the wing, I find that it has reduced my incidence of tip stalls as well. So yeah, so sort of more of an internal type of aileron flaperon there if you want. But I have them switch selected to be spoilerons for high alpha, but for most of the time they're just acting as ailerons. Okay, so what I did in the back end here, let's start with my elevons. I wanted to downsize my elevons to be a bit more scale dimensions. On the stock F18, they're quite a bit bigger. So all I did there was, again, I just looked at some pictures and some diagrams. I sort of measured the wing and I measured the elevon span, if you want, on pictures of the real F18, and then I sort of figured out, you know, got my dollar store calculator out, did a little bit of math, and figured out, okay, well, if the wing on the real one's this wide, or you know, has this span, and the elevons are this span tip to tip, then I took, you know, this wing and versus this span and kind of came up with a more scale size. So these are actually about, they end up, I think by the time I sand them, they're probably about 15% smaller than the stock. So what I did was I just went to the tiled plans and I printed them off. Actually, I think I printed them off at 88% of the plans, and then, you know, including this piece. This piece on the stock build would be a floating part of the floating or flying elevon. I made mine into a horizontal stabilizer, which I'll talk about a bit more. So I end up with smaller elevons, and again, there are some pictures in one of the blog posts that I sort of had to move this, do some drawing on the plans after I printed these out on the tiled plans to move these nacelles inwards. Otherwise, they'd be way over here, and it wouldn't look like an F18. So as you can see, I went with sort of the, you know, fixed horizontal stabilizer and just, you know, the hinged elevator slash elevon. What I've been finding, you know, many park jets now are designers are doing this. Personally, I think it makes sense because now, you know, this is a horizontal stabilizer, and, you know, funnily enough, it actually provides stability, or at least in my experience. So, and it also makes for a smaller moving area, which, you know, as long as I got enough movement here to make the plane do what I want it to do, the less actual moving surface, then the less drag, less turbulence, and less instability I have when I'm flying my plane, at least from my experience. So, anyway, and then what I also did was I cut about 3/8 of an inch off of the back where the normal hinge line would be on the back of this back plate, so that I could move that further forward. And you know, in order to make it look better, I moved these the slots on the bottom here and on the top where these vertical stab rudder pieces go. I moved them forward by about 1/4 of an inch just to kind of keep things, you know, in the proper ratio. You can see with my rudders, I've probably, I'm not sure if I'm double, but I'm almost 75% larger than the scale rudders. I like to run my hinges and all of my linkages and control horns on the outside. I find it easier to adjust, but the main reason I do that is to keep this prop wash area as clean as possible to help for maximum clean airflow and efficiency going through there. And same thing on the bottom. That's why I run all of my servos and push rods on the outside. I also just find it's easier for building to adjust them and then, or to install them and then to adjust them a little bit later. Now these are pretty long push rods, so I make my push rods myself out of 2mm carbon rod with some inexpensive nylon clevis I get from Hobby King and little adjusters. So these are longer than 12 inches, so if you're using your standard Dubro push rods, you'd have to have your servo quite a bit further back, or do the stock thing. But this way I'm able to have this weight up where I wanted it to be. Okay, so you can see a little bit different. Now this is just more technique, it's not really a modification. Hopefully you can see there, I have KF4, so same thickness top and bottom. This is actually paperless dollar store foam, which you may not be able to get where you live. It's readily available just about anywhere in North America anyway. Once you take the paper off, it's about 4.5mm thick. It's very, very cheap, and I find it's just the right thickness to give me the good stability that I want in the wind and at speed, and still is effective, but doesn't make for a super thick profile. And then I taper so I have a symmetrical shape just for for the smoothest airflow possible. The other thing that I do, obviously up in the front here, I shave this down and then I use some super lightweight finishing spackle and fill those slots, mostly just in the front part here, to try and get as clean, keep the air that's hitting the nose as clean as possible as it transitions back over the plane. Obviously, as the air is traveling over your plane, it's eventually going to get dirty and turbulent. There's just no way about it. But if I can start it off as clean as possible at the front, moving backwards, that just helps. And you can also see here on the maybe on the trailing edge of the wing, my vertical stabilizer rudder, my horizontal stabilizer elevons, leading edge and trailing edge of my prop slot. I've also sanded those so that they're symmetrical, come to a symmetrical taper. It just makes, I find it makes a huge difference, and in testing at the field between sanded and unsanded, speed may not necessarily be something you are worried about, but I instantly gain about 6 to 7 miles per hour average using the same power systems. So even if speed isn't your thing, but what it tells me is that I have considerably less drag, much cleaner airflow. So let's say endurance is more important to you. Well, the less work that your power system has to do to keep your airplane flying at a particular speed, the more endurance you're going to have, et cetera, et cetera. It is a bit messy and a bit fussy, and I know a lot of people, it's beyond what they want to do. But anyway, for me, it's kind of free speed and free drag reduction. An hour or so of work and a little bit of dust, but pardon me. I forgot to mention here, this is 3mm carbon tube that I put in the horizontal stabilizer, and it's also extends down below the deck here when it glues in, so it's really the end down here is really locked in. With these angled vertical stabilizers on the F18 as opposed to ones that are straight up and down like on the MiG and F15, stuff like that, I find that these get a lot more flex and banging around to them when you're flying or in windy conditions or when you're doing high alpha. So just a little bit of added stiffness. Again, it adds a few grams, but it's, in my opinion, it's weight that provides great function. So that's why I did that there. All right, so as I said, got out to the field. Initially, when I moved the motor forward, normally on the stock F18, hopefully you can see this, on the stock F18, the center of gravity would be pretty much right about here where the wing breaks away from the lurks. So I just took a bit of a wag and thought, okay, I've moved my motor forward by about 1 inch, so for my maiden flight with the new setup, I just moved my center of gravity back by about 1 inch, and I started with that. And luckily, you know, it was the F-18 is still a pretty darn stable plane. It didn't do anything crazy, and you know, so I was able to start dialing it in. Now, again, this is something maybe that's a bit more advanced. You know, a lot of folks maybe you just want to, okay, it balances on the point where the designer told me it should, and I'm okay. Now, most of RC Powers planes, and they, you know, they admit to this because, you know, they hats off to them. They, you know, they build planes and design planes that are geared towards beginners. They tend to have the center of gravity a little bit further forward than neutral, because normally when you're learning, having an airplane that's a bit nose heavy is better than having an airplane that's tail heavy. Tail heavy airplanes are very hard to control, whereas nose heavy airplanes, I mean within reason, are a little bit easier to control because, you know, you're pulling back, and, you know, if you run into problems, the plane is always going to come back towards towards Mother Earth. So that's where I started. Now, you know, I just not really challenge you, but I give this a try and see how your plane looks. So at one point in time, when we were developing the MiG-35, Stefan did a bunch of research, and we started doing this, it's called an arc test. And essentially, you know, you set your airplane up, you know, you're flying straight and level. I go about probably 60-75% throttle, pull the nose up in about a 30-degree angle of attack, and then, you know, obviously do this nice and high. Don't do it when you're 5 feet off the ground. Chop the power, and then watch what the plane does. So what I'm striving towards is to find neutral CG. So not nose heavy, not tail heavy. Just basically the plane should just, you know, if you got it trimmed properly, you know, it should just be nice, stable, and balanced. And as you get close to that neutral CG, you really start to feel the plane just be balanced. You know, I hate to say it, but it just feels like a much happier park jet, at least in my experience. So anyway, what you're looking for, you chop the power, and it should just sort of, you know, slowly continue a nice gentle arc up and over the top, and of course eventually the nose is going to drop as it loses airspeed. But what, you know, if you do that, and then, you know, you chop the power, whack, nose drops, obviously it's probably still nose heavy. You chop the power and it just sort of sits there and waffles, and maybe the rear end drops, it is probably tail heavy. And then what you can do is, you know, again, nice and high, and believe me, I'm not a good inverted pilot. I still need a lot of practice, but roll the plane inverted, and then, you know, it helps you to cross-check where the center of gravity is. If you need like full up, you know, full forward stick to keep the thing level, you're probably still nose heavy. Traditionally, I find on most of these park jets, I think because of these big tails, your nose seems to get pulled down anyway. So right now, when I fly this plane inverted, I've got maybe about 20% forward pressure, just a little bit of forward pressure to keep it level. So it just, and you get to the point where it just feels really balanced. The other thing I should point out is I personally, this is just something I found, I personally, when I'm checking my CG, I personally like to have my airplane sitting upside down and measure it from the top rather than from the bottom. I just find it's easier, than I'm not mucking around with the you know, servos and push rods and all that sort of stuff. I just find that works easier for me. Okay, so that's how I did the test. So as we moved along, and initially, you can see pictures, initially I had the battery probably 2.5 inches further forward to be balanced on this original CG that I started off with. So it takes some time, and it takes some patience, and it's best if you can do it when the wind is calm, rather than you know, a howling gale, because then you get more accurate feedback and results. And each plane is different. Like what I noticed with the F-18, because it's a more draggy plane and it's got that straight wing compared to the MiG-35, is that as I topped the arc, it slowed down a lot more quickly. Like it didn't sort of carry the momentum. So you have to sort of keep that in mind, so that, you know, if you see it, you know, you chop the power and it's, you you know, it's dropping faster than maybe other planes you've seen. Each plane is obviously different. So probably about 12 flights, I guess, it took me to sort of get confident that here is where my my CG is. So that's about 1 3/4 behind stock and about 3/4 of an inch behind where I initially projected that it might be after I'd done all this modification. So what happens now is that this is where my battery is when I fly. So if I measure from the front of my battery to this tip of the motor, this is where, again, I mentioned 60% of my weight of my plane is right in here. This is only about 9.5 inches for a 42.5 inch airplane, and you can see here's my CG. I've got everything very, very close to my center of gravity, and it makes this plane what I was hoping for. It makes it really crisp, really precise, more agile than it used to be. Like it's really a quick little thoroughbred. When you want to get some quick, clean, and precise aerobatics now. And it also turns and does everything far more effortlessly. Like I need very little control surface deflection to get it to move. Again, I like that because the less I'm deflecting my control surfaces, less drag, less turbulence, thing just flies a lot cleaner. So I'm very happy with that. So just real quick about the KFs. So as I started moving, I mentioned I already made them about 1/4 of an inch shorter than per the plan because I reduced the width of the wing. At some point in time, as I was getting along here, I started to get those feelings of mushiness that I talked about, or having more difficulty pulling out of a power dive. So I trimmed about 1/8 of an inch off the back here. Just took a ruler and my knife and very carefully sliced that off without slicing my wing, and it automatically cleaned that up. So essentially now, if I just go in straight here, the KF is at about 40% of the wing chord here at the root, and about 38% out here at the tip. And it just, again, my feeling, but it just feels like a very happy, well-balanced park jet as a result. So, okay, so I'm just going to fire things up and show you how little control surfaces I need to get this thing to fly around. So you will note I do set up my planes, before I get too far, I do set up my planes a little bit differently than some folks do. During our development of the MiG-35, when Dave joined our team at NAMC, he steered us onto this book from first U.S. RC flight school, written by a gentleman named Dave Scott, that talks about airplane and radio setup for more precise type control. And part of his theory was, I know 3D flying is great, don't get me wrong, I'm not saying 3D flying is bad, but 3D flying has become such a big part of the hobby that as he was running his flight school and he had students going through there, he was starting to see that people, even for planes where they wanted to fly more precisely, were setting them up for 3D. So, having the push rods way out at the end of the servo, huge giant throws, and often having to compensate for that with tons and tons of expo. I mean, expo is very good, don't get me wrong, I'm not saying, expo it was certainly my friend when I was learning how to fly. It can take a lot of the twitchiness out of a plane. But as your skills develop, and you want to have a little bit more feel for your plane and have smoothness, I found that when I transitioned my way of flying to be more, building my planes, setting up my planes, and my way of flying to be that more precise, it was again a huge quantum jump in how I was flying. My flying, I feel, is far more smooth and precise as a result. The other thing is that you reduce. Just try this. I noticed this. I tested this. If you have this push rod all the way out at the very end of the servo arm, and you just do very, very slow, gentle movements, what I noticed was the control surface would be very jerky as it moved. and then as I moved my push rod in close to the servo, as close as I could get it with these little connectors, those same little movements, the control surface moved much more smoothly. So I wasn't getting that sort of, not chatter, but I wasn't getting that sort of oscillation. Makes it much smoother. So anyway, again, that's how I set up my planes, but it's relative to the amount of control surface that I need to fly. So I only have 15% expo in the pitch and the roll, and about 25% expo in the rudders right now, because I'm just getting my my high alpha thumbs and brain back, and having 15% in the rudders was just a bit much, so I needed to smooth it out a little bit. So I noticed right away here that I've got to do a little bit of adjustment before I go to the field the next time. But so this is, I only have just over an inch of yeah, you can see I need some adjustment there. Just over an inch of travel in my Ailerons, and that is plenty. It's actually a bit more than almost what I really need. What I try and do is I try and set my planes up so that I have just enough control surface, but what I do like in the pitch is I like just a little bit extra, you know, that sort of emergency that, you know, you're heading towards terra firma or a tree or a fence or something like that, and you're like, whoa, and you just need to hammer the stick and give you that little bit of extra. So I like to put a little bit of extra in the pitch just for emergencies. I do like to fly with ailerons, so my travel in my elevons is also just over an inch, maybe an inch and an eighth, I think. I have about 5/8 of an inch of travel in my aileron. This plane, because it's a big, you know, big wide wing airplane, I find I need a little bit more aileron throw if I want to have really crisp direct roll. So I started off first flying, I only had about a half an inch of travel, and it felt a little bit lackadaisical in the rolls. So for me, I cranked that up to about 5/8 of an inch. Then I have about an inch and a quarter, I think, inch and 3/8 one way on my rudders. So lots and lots of rudder authority. That's plenty for thus far for high alpha. I can see I need to adjust my rudder sort of a little bit. I don't have any trim. Anyway, I guess the plane warmed up sitting inside. My settings have gone a bit wonky on me. So anyway, I have to check that. And then I do have, for high alpha, I do have spoilerons. Again, this is probably more advanced, but I just wanted to point this out. Either I've built all 4 of my F-18s wrong, which is quite possible. I'm the first one to admit my mistakes. Or there's just something about this plane. All of my F-18s always wanted to pull or roll to the right, which is opposite to normal physics. Normally your planes want to roll and pull to the left because of prop wash and prop torque. So what happens is when I try and high alpha with this, is it wants to turn right all the time, and I sometimes have to really fight it to get it to come back the other way. So what I experimented with, I sort of call them differential spoilerons. So this spoileron is deflected about a half an inch, which helps to keep the nose up when you're doing high alpha, and I only probably have about that much deflection in my elevons in order to keep about a 40 to 45 degree angle of attack doing high alpha. So to try and help myself to help my rudders out, is I deflected this one about a quarter of an inch more. This is a Turnigy 9X with the ER9X firmware, so I have a considerable amount of ability to program it, so that's worked out really well for me. But anyway, that's probably more advanced than some guys want to mess around with, but if you're out at the field and you want to play around with stuff, there's all kinds of options. Alright, so overall I'm exceptionally happy with these modifications. I strongly suspected that the changes that we're going to make the plane more agile and precise, and really a lot of fun to fly. Not that the old stock F-18 wasn't fun to fly, but again, we all grow and progress in the hobby, and I was just looking for a little bit more out of it. So I'm very, very happy with how it looks, how it handles, and There's some things I'm going to continue to play around with. The F-18 is a bit bottom heavy, which is good for stability and for self-righting, but if I take the plane and I hold it, with one finger on the bullet nut and one finger on the nose, it automatically starts to roll itself upright, which is a great feature for a plane, for a beginner intermediate, but it means that, it's when you're in a turn or whatever, that it's not balanced sort of in the vertical CG. So my partner Stefan did an excellent video on calculating your sort of center of mass with respect to the vertical CG, I guess, if you draw a line through here, which affects your yaw and things like that. So I'm going to play around with maybe raising the battery up just a little bit more in relation to the wing plate. I think what I'll do is I'll just start off, I'll do the calculations, kind of get a rough idea how much I need to raise it based on the formulas that Stefan shared with me. And I might just use like some scrap pieces of foam with Velcro on either side and just raise it up a little bit and see how we come along, just for fun. So that's about it. And again, like I said, I really need to keep working on my high alpha. It doesn't have as broad as sort of a stability slot as the stock F-18 did, because I've shortened this moment and pulled the CG back. When you get it in that slot, it's very, very stable, but the slot's a little bit smaller, so I've gone from balancing on the top of a pickle jar to balancing on the top of a Coke bottle almost. I mean, maybe not that ratio, but so if I start to get off of that slot, it falls off a little bit quicker. So obviously I could fly with the battery way forward just for doing high alpha, but I like to try and have my plane set up so that I have the biggest, I can fly it in the largest part of the flight envelope, and then just work on my skills for those, for those extreme ends of the flight envelope, like high alpha. So I'll continue to work on that. But I'm about 95% there, and like I said, very, very happy with how my mods worked out. It's just great fun to have an F-18 again back in my hangar. Like I said, I have a real soft spot for the real plane and for this model. So it's just so exciting when I saw that plan form in the sky for the first time after about a year. So I appreciate you watching. Again, be tons of links down below in the comments. If you have any questions, comments, feedback, please post them on the video. And I'll also put my Migzerus, Scott@migzerus.com email address if you want to email me. For more information or why I did certain things. I'd be more than happy to discuss them with you. Again, a lot of these things I did because of the form and function I wanted out of my plane. Maybe you're not interested, or maybe there are things that you don't want to do. Maybe you just don't want to do one or two, and that's all fine. That's the beauty of scratch building. You pretty much have a clean slate to do what you want to do. But another caveat, if you're just a beginner, please, I encourage you, just go join the site. You get the plans for free. Build it stock exactly the way RC Powers tells you to. Try it out first, and then you can start playing around to tailor the plane to fly the way that you want it to fly. So thanks again for watching. Again, big shout out to Splash Balls for getting me off my butt and dusting off my one set of F-18 V3 plans and getting this bad boy built. It's been a ton of fun, and I look forward to having quite a bit more fun with it over the coming weeks and months. So thanks very much for watching. Wishing you blue skies and calm winds. Take care.